In this tutorial, we're going to look at the drawing mode function. I'm opening up a data file containing a WaveMark channel. This type of data has more drawing modes than any other channel type. Right-clicking on the data, I can choose channel 1, then duplicate channel. Right-clicking on the duplicate gives me a menu which includes channel draw mode. The channel draw mode dialog for channel 1A gives me a drop-down list of rate, mean frequency, instantaneous frequency, raster, dots, lines, waveform, cubic spline, WaveMark, overdraw WaveMark, and state. Compare that to channel 2, which is a simple event type channel, and our drop-down list is much less populated. Reverting to channel 1A, let's look at rate as a drawing mode. As we press draw, the display changes to show a histogram with 1 second bins, holding the count of the number of events per 1 second. Changing to 5 seconds, and you can see the difference. Changing now to mean frequency and per minute, we can display the data as beats per minute. Switching off the per minute box, and we can see that the y-axis changes back 2 Hz. On to instantaneous frequency, and here we can see 4 different drawing styles. Default for backward compatibility, dots, lines, and skyline. We can choose with dots the dot size. We can also see line mode, and finally skyline. Zooming in, back to lines, and back to dots. Changing to raster draw mode now, and we have a new item for trigger. Here we're using channel 2, a simple stimulus mark, and this now shows it as the 0 position with events distributed about it. Note the colors in the raster representing the color of these wave marks. To dots mode now, and you can see that at each marker there is a code as well as a dot representing the time of the wave mark. With lines, we can see simple tick marks indicating the event occurrence. Now to waveform, and we can see the original drawing mode for the WaveMark channel. Cubic spline now, and you'll see that the uppermost channel is now drawn so that all data points are joined with smooth curves. With WaveMark mode enabled, we not only see the waveform, but also the associated marker. Overdrawn WaveMark is a special drawing mode. We can see the current spike separated from the rest of the data by a line. As we zoom out, and adding more data to the display, you can see more and more spikes adding to the display. In this mode, we can draw a line from point A to point B anywhere in the display, and if any spikes cut this line, then they can be reclassified. This is also true of wave marks drawn as wave marks or as waveforms. Finally, state mode, where a marker's code is drawn as a representative color and duration. It is now possible to show the code, and if this were a text mark channel, any text associated with it. Reverting to lines mode for our duplicate, I'm going to call up the cursor regions dialog. The measurement cells here are empty until we have added cursors. Adding cursors to the data with Control and 1, Control and 2, we see that the dialog becomes populated. Changing the measurement to sum, which should be a count of the events in channel 1A, we have a count of 3. But if we now change the drawing mode to waveform, you will see that we no longer get a count but the sum of the data points. So it is vitally important that you remember that depending on the drawing mode, the answers that you will get from the cursor regions and any other cursor-related measurements are dependent on the drawing mode. For those of you who wish to use the drawing mode within scripts, the DrawmodeG command, as shown here in the help, will give you the command and arguments.